Hello, we are at 720910. That is right. This is two-step equation solving. There are three-step equations in 7.2. Those will be on the next one. Wanted to keep it separate. So let's look at a bunch of these. Probably got 8 of them here for you. These are two-step equation solving. So we got more than one thing to do here. Our goal here is to, of course, solve for x. We need to get x by itself. So the first thing that you're going to do on problems that look like these are what two-step equations look like, is we're going to look for the constant term, which is the number without the x, and we're going to do the opposite of what's given there. So if it's minus 9, we're going to add 9 to both sides. Same thing to both sides. And this is just like anything else. Once you do this, it gets easier. 27 plus 9 would be 36, and then we would divide by the coefficient, and x would equal 12. All right, the next one, we'll go over here. If you want to try this, go for it. Hit pause, try it, do it. Here's plus 7, though. We're going to subtract 7. Pick up the pace just a little bit, but I don't want to lose anybody. This is now cancels to 0. This is negative 6x. That just gets brought straight down. 67 minus 7 is 60. And we divide by the coefficient. And remember, when you're dividing by the coefficient, you take the negative with it if it's there. So that cancels. That thing should cancel, leaving you 1x equals, and we got a positive divided by a negative here. That's going to be negative 10. Negative 10. Here are our answers. And moving right along. These are different because the x is on the right side. Usually they're set up like this, but if they're like that, you should be able to figure that out. All right, so let me show you how very similar this is. Again, we're trying to isolate the x, get the x by itself, and this says plus 9 right, or minus 9 right there, so we have to add 9 to both sides. Now be sure, there's a little tip for you. When you first learn this, you want to make sure those are over top of each other like that. So don't get the 9 over here under the 4 when you do that. It should always be lined up like this. All right. So let's do it. This will be 7, and that's a funky equal sign there, equals negative 4x. And here we would divide by negative 4 on both sides, negative 4. And oh, look, we get a fraction. And that's okay, people. It's okay. So sometimes this doesn't come out even. So this is just 7 over negative 4. You don't do anything else to it. 7/4 negative. 7/4 negative. You know, a lot of people think they've done that wrong if they don't come out with a whole number like that. But most of the time, that's what happens. Let's see if it happens here. This 9 is positive, so we need to take it away. Take it away. That way it becomes 0. You can see how that right there is going to become 0. Subtract 9 from both sides. Make a very wavy line there. And this will be negative 12 equals negative 2y in this case. And we divide by that coefficient. That's usually the last step all the time. So we divide there, and that would cancel. Like I said, if you like to do that, go for it. 1y would equal positive 6. Now, why is it positive 6? Because it's double negatives, and we're dividing. All right, now watch it pop out there like it shouldn't, and it does. It does every time. I don't know why, but it does. Here we go with some more two-step equations. All right, so we're going to do this now. This time, we have stuff on the left side of the equal sign that can be put together. Anytime you have that, you put it together first. Now, I picked this one because something odd happens. Watch. I have 4x and negative 5x. And if I put that together, 4 minus 5 would be negative x plus 7. Let's bring that 7 straight down. Remember, that's negative 1x there equals 12. Well, now I have it down to a one-step problem, sort of, even though that's negative x. I don't know if that's happened very much before. I don't remember it happening. It may have happened on a homework problem. but we subtract 7, and that equals 5. And over on this side, it's not just x this time, it's negative x. It's actually, watch this, I'll actually write it this time. It's actually negative 1x equals 5. That's what it is, and we have to divide by that negative 1. Now I'll show you a little shortcut on how to do that, but that's what's going on here. That would cancel, and x would equal negative 5. Now if you look to how these two things are related to each other, if you ever have a negative x equaling a positive number, well then you can just flip the signs. So x would equal negative 5. X would equal negative 5. If it came out to be, say, negative x equals, just to throw this out there, negative 7, you would still switch both signs. So this would be x equals positive 7. All right? Just throwing that out there. On this one, change colors, getting boring. This 3x plus 4x, that's going to be 7x. So 7x minus 1 equals 5. Now where'd the minus 1 come from? Right there. That's just brought it straight down. Just brought it down. Now we're to our two-step part that we've been practicing. If you want to pause it, try it. But we're going to add 1. Wavy line. Didn't intend for that to happen there, but 7x equals 6. And here we go again. This is going to be a fraction. You can see that. This is going to be a fraction. Divide by 7, and x will equal what? Well, it's just 6 divided by 7, which we call the fraction 6/7. 6/7. You know, so I'm trying to show you in this video the ones that don't always come out completely even and slick and things like that. Here's the last set of two-step equation types. What is different about this? Well, we have x's on both sides, but only one number. So when this happens, you have to combine the x's. In other words, if I have positive 8x over here, I need to subtract it. Subtract 8x. Now you don't put it under the 20, you put it under this so that becomes 0. Because we want it, what we want it to say is x equals and then a number. Now watch, I have to do the same thing to both sides. I can do anything I want to this as long as I do it to both sides. Interesting thing happens here when you do that. This would be 5x equals 20. This 20 gets brought straight down there. All right, so 5x equals 20, and then we're at the point now where we're just dividing by the coefficient. So that cancels. X equals 4. Final answer. Final answer. This does take some work. Here we are again. Now, if you want to try this, it's the same sort of thing here. We have 6x, and I want to put this set of x's over here with this one. So I have to subtract to get rid of it on the right side. Notice these equal signs should be lined up. Okay, it should be just in a line like that. All right, so we have equals over here, and then this would be 9x equals 30. All right, 9x equals 30, and then we would divide by 9. Oh no, 9 doesn't go into 30. It doesn't matter. It does not matter. It's 30 over 9. 30 over 9. Now, does that reduce? Well, if it does, you have to reduce that. It looks like 3 is a common factor here. So we can divide this by 3 on the top and bottom to get 10 thirds. 10 thirds. Now, a lot of people gonna want to go, well, wait a minute, do I have to leave it 10 thirds? Can I make it 3 1/3? Sure, you could, but I don't recommend it. This is a better answer here, 10 thirds. All right? And the reason why is if you were to check this answer, in other words, you could plug 10 thirds in for these x's, and one side would equal the other. If you don't believe me, try it. And in fact, I encourage you to try it. If you plugged in 3 1/3 into that, you would have to change it back to 10 thirds. So that's why in algebra, you're always told to leave it improper. Leave it improper, but make sure you reduce it. 30 ninths is no good. 10 thirds, final answer. Have a good one.